Okay, we were in the middle last time and we were discussing the different elements of evolution. We spoke about three aspects of evolution that need to, three aspects of life that need to be addressed. One is the transition from lifeless to life. One is the transition from the simple to the complex. And one is from the complex to man. And we said that the theory of evolution itself addresses simple to complex. It tends to see man as just another version of complex, so there's no need to explain that last phase, that last leg. And the bridge between non-living to living is going to be a different discipline. It wasn't addressed really by Darwin. It wasn't addressed by the main aspects of evolutionary theory, but it's something called abiogenesis, which is trying to explain how the lifeless became life. And there is obviously some difficulty explaining what is life. We gave a general explanation of something that is an active, self-organizing organism and so on. We were speaking about the cell, and we mentioned that a simple cell is anything but simple. We quoted there are approximately 60 to 70,000 different proteins that each one has a very specific function. We also touched on the conundrum of DNA, protein. Proteins are manufactured by DNA. DNA is a written code of instruction which is completely, it has absolutely, it's not thing, but rather it is instruction. And did the DNA come first? If DNA came first, it's very, very hard to understand how chance could have written a book. It's not materials. It's literally a code of a chain of molecules. On the other hand, proteins themselves without DNA would just finish and die at that point. There's no way to do anything without the DNA. I would like to add another point about cells and living things and DNA, etc. This is from a book called The Way of the Cell. It is written by, we'll find his name in a minute. This is The Way of the Cell, Origins and Order of Life. It is written by somebody called Franklin Harold, who is Professor Emeritus of Biochemistry and Molecular Biology at Colorado State University. Same thing. It is also it's a science book published by Oxford University Press, which simply, I just have these. These are books that I've read at random. I wasn't looking for anything. And he talks about cells. Also an extremely readable book and very well. Now, he begins to understand, he has a chapter called It Takes a Cell to Make a Cell. Molecules into cells, paradigm wanted. I seldom open the hood of my car other than to check the oil, for the tangle of wires, tubes, and terminals is unintelligible to me. I guess he's a biology professor only. I must take my mechanic's word for it that they make the wheels go round and they provide the safety, comfort, and compliance with the law. The massive, and I can't read this because I did not photocopy it well, but at any rate, the E. coli stirs similar wonders, and but the sheer formation of it overwhelms the faculties. Unfortunately, in this case, there is no higher authority to which to turn, because the point he's going to be making is that we are trying. It's like somebody were to ask you, how does a car work? And the person says it is X amount of iron, X amount of chrome, X amount of copper, X amount of rubber. The prevailing framework for thinking about biological organization comes in the form of the genetic paradigm. It builds on the established relationship between genes and proteins, but vastly enlarges its scope. Um, so the understanding that we have is that the genes determine the cell. Now, he says the genes determine the recipe. He says there is nothing about the physical layout of the cell that is mapped on the genome. All that it does is it's a recipe for producing the proteins which it comes from. So he says, stated thus, the genetic paradigm is not a hypothesis drawn from, I think the word is infallible propositions, but what is called in German a Weltanschauung, a worldview that expresses the reductionist spirit of contemporary science. Now, for instance, he says, growth and morphogenesis in the E. coli, the classic proven ground of the genetic paradigm, forces one to ponder the inward meaning of the potent metaphor. Form and development clearly come under the gene's writ, as attested by many mutants in which these features are altered. So, we know that if we destroy some of the genes, its features, its shape and so on, are changed. Though not explicitly specifying the genetic instructions, a rod with rounded caps must be one implication of the set as a whole. Just as the delicate flavor of the marble cake that my wife bakes on special occasions is nowhere mentioned in her notes. But wait, the product of those genes, insofar as we know them, turn out to be enzymes and other proteins that perform essential but mundane local tasks. In other words, to the extent of what we know, a gene simply produces a certain type of chemical. Knowledge of the genes and what they encode is nowhere near sufficient to explain how the cell elongates, divides, and shortly produces a pair of rods with rounded caps. What we seek to understand emerges from sociology of molecules, not their chemistry, and carries us into a different layer of reality. Indeed, how could it be otherwise? A growing cell is not a self-assembling set of puzzle pieces, but the product of generative process mediated by multiple molecules, the physiological pathways deployed in space. The reactions that shape a cell have, of course, a chemical dimension, but unlike their fellows in the test tubes, many of them display direction, location, and timing. Cell biology is about chemical and physical events that take place here rather than there, transport matter from here to there, not now but later, when called for. In other words, the picture that we have, where if you take genes, they produce proteins, it accounts for the metal of the car, for the rubber of the car, for the chrome of the car, for the plastic of the car. But where, take a look at a human being. If our physiology is off by a bit, the nose happened to be a little longer, person looks misformed. If the leg is a drop shorter, where are the instructions for the shape of it? People have very distinctive shapes. Children carry shapes of their parents, and in a very noticeable way. So we have a general form, and where is it? Once your eyes have opened to these upper levels of order, as mine were by Peter Mitchell 30 years ago, you see them everywhere. E. coli, like all cells, we look at cells as little blobs of protein. That's absolutely not true. E. coli, like all cells, practices biochemistry with an attitude. And he lists them: vectorial transmembrane reactions. Vectorial means directional for those. It means it's not diffuse. It has very specific directions. Vectorial insertion of membrane proteins. Localization of chemical receptor proteins. There's clear places where different receptors are located. It's not random. Direct assembly of the FTSZ ring, which I profess complete ignorance. Diffuse elongation of sidewalls, finding the cell's midpoint, spatial markers for morphogenesis, orientation of murin links by stress, and many more. So, cellular organization is chemical and molecular, bred in the genes. But a cell reaches much farther, flaunting capacities that are rooted in the operations of a larger unit. If you think of the genome as software, then cellular organization corresponds to the interpretation of the program by its own unique reader. So something is reading this DNA and saying, it's like the difference between, let's give you a muscle. If you go into a pharmacy and you get a prescription, for those of you who who remember before the pharmacist used to just take pills out of a big bottle, put them in a small bottle. They would take different chemicals and mix them together and weigh them and measure them. That's a very flat process. Let's say you send somebody to an orthopedic specialist to create a brace that will help him walk better. That's not mixing anything. He's got to think and decide on form and structure, etc. Somewhere there's a code that's telling it what it looks like. And even we think of a cell as a blob of protein, but it's by far more than that. So how did that get encoded? The very first cell needed to have, it's not just a hodgepodge of stuff. It needed to have a very clear layout. So where does that come from? And how does the layout get it translated? When you're dealing with chemicals, it's okay, a little nitrogen, a little hydrogen, proteins touch other proteins, they tend to make duplicate proteins. It's like, as simple as when you put a foot down into sand, it makes an imprint. Forget about all that, but there's so much more written in, we don't even know where it's written in. And again, it's a book that does not deal with religion, it has no conclusions about God. He's dealing simply with the cells, a very scientific way, and he's saying what we know and understand about it is a very, very simple aspect of it. So it's true, I'll give you a muscle. It's true that if you take the yeast out of a cake, it will be flat like a matzah, and therefore it is so in the direction where the chemicals affect the shape. If you take a gene out, a person might have a horribly disformed, he might not have a leg, something like that. That is true, but having yeast in the cake doesn't yet make a cake in it. If you don't put in the right amount of sugar, you don't put in the right amount of warm water, you don't plan for it, you're not going to have a cake. And if you need a cake in a specific shape, you can't even just put chemicals in. You've got to stand and shape it. You want it to look like a Torah, you want it to look like, I don't know, some birthday thing or whatever it is. So there's a whole dimension that in the simplest cell that we don't know where it's encoded. So how did that get started? Life needs direction, it needs organization, it needs time. It needs to know that, just like every computer must have a clock in it, because the instructions of first, then is an element of time. The chemicals in a cell are not running around, each one trying to do what it wants to do and coming up with a result. There is a very clear timing. This happens first, it takes in the material first, then digests it, then lets out the waste product. While it's doing this, it's not doing this. While it's doing that, it's not doing the other thing. So it has a built-in clock of sorts. It has a built-in sense of direction. It has a built-in sense of orientation. Where did that come from? Those are the puzzles that he raises. I want to finish this topic, and again, the truth is, like I said before, the to'elos is not simply in boiling down. If the bottom line is that you heard that life is very complex and couldn't possibly reach for itself, it will erode, because that sentence does not. By reducing it to that sentence, you basically are leaving open a whole new slew of whatever it is. Thinking about it and really, sort of sipping each part of it and reading about it is really a great enhancer of Emunah. But I want to finish it with another book, which really, it goes to the heart of two things. It goes to the heart of this issue, of the formation of living beings, and it also touches on a very human factor of how much non-belief can become a form of belief. It's a very important issue when dealing psychologically, where the position is scientist is pure, objective, looking at things completely objective and willing to accept any conclusion that's rational, reasonable, and good, whereas a religious person comes in with a hang-up and preconceptions. This was a book that I read that I really, really liked, and it floored me in its conclusions. The book is called The Ascent of Science. Of course, a book that's written by a Jew, by an Israeli. The name of the fellow is Brian Silver. The book is published in 1997, which is, I think, 10 years is recent enough for us. The other books were published later, actually, the ones I read before. Brian Silver was professor of physical chemistry, Technion Israel Institute of Technology. Very, very prestigious institute, very prestigious job. He died in 1997, just prior to the publication of this book. The book, The Ascent of Science, has two things. It touches on the important subjects of science in a very cogent way. He is really understands his material, draws, he presents the way thinking developed on different issues, whether it's quantum physics, whether it's biology. It's definitely a very, very good book. Also published by Oxford University Press, also gotten at the bargain prices. And the book has another angle. Besides a science book, just telling you what science, I'm reading from the flap of the page, and I think it's a good description. Throughout the book, it is science as the height of human reason, and reason as the surest guide to knowledge that enlivens the story of our emergence from ignorance and superstition to the ability to fathom the deepest mysteries of nature. In other words, the book is saying mankind lived in darkness. We had a lot of garbled mythology to teach us about the world, and as science, as the sun of science began to rise, pure human reason shone, and we went from Afela Laora, Mishibit Legula, and so on. For anyone interested in but intimidated by scientific enterprise, the Center of Science provides an inviting assessment of the discipline. That it does do so, yes. That it does so without diminishing the complexity of the awe-inspiring power of science is a major accomplishment. Basically, I think that's a very good description of the book. Now, he goes through how evolution is a fact. He brings, and again, he's a very cogent writer where he brings the things that were discovered, the possibilities of how we look at it, and the conclusions we came to, and so on. The last part about this is called Chapter 27. And by the way, he does not deal only with biology. He deals with all disciplines of science. He seems to be a very, very well-rounded person. But specifically biology and so on. The chapter heading is The Origin of Life, Take Your Choice. And then he has a quote from Schopenhauer: "To believe that the physical and chemical forces could by themselves bring about an organism is not merely mistaken, but as already remarked, stupid." He will unfortunately prove it. I do not know the origin of life. This is him talking. Those of us who hold, like I do, that life emerged spontaneously from inanimate matter are, we must admit, at a distinctly embarrassing disadvantage. We have not yet come up with a convincing mechanism for abiogenesis, which means the beginning of life. In his presidential address to the 1871 meeting of the British Association for the Advancement of Science, Lord Kelvin stated, "Dead matter cannot become living without coming under the influence of matter previously alive. This seems to be as sure a teaching of science as the law of gravitation." If he is right, which I doubt, then life must have been present in the universe for all past time, which means it was infinite. Either that, or we must turn to the finger of God in the Sistine Chapel, and indeed, after reading this chapter, you may well conclude that there's our only hope. Just not to be motzi las, this person holds on to his emunah and kfira staunchly, and he does not have to go on to that. He actually, during the 19th century, abiogenesis was given a boost by successful synthesis of organic molecules and inorganic precursors. People in labs have synthesized enzymes. But the fact that we can synthesize amino acids and nucleic acids from inorganic starting material does not explain how life started. We are intelligent beings who can purposely bring together chosen chemicals under carefully controlled conditions. This is very different from accounting for the spontaneous formation of living systems in an inanimate world empty of all intelligence. And we have come nowhere near creating life in a laboratory. Insulin itself is not life. It's an enzyme. That's all it is. Hormone. Now, he brings down those who prey upon the poet's harp. He quoted something: "Know that in tackling the problem of the origin of life, there are two basic and interdependent questions that have to be answered. Living systems are based on extremely large and complex carbon-containing molecules. How did the large, complex carbon-containing molecules originate in the first place? Second, living systems are very highly organized. The living cell is a very spatially structured entity. Do you remember what we saw from a living cell? It's got direction, it's got timing, operating through a sophisticated system of catalysis, transport, and feedback mechanism. A cell is not a blob of egg white. A cell is an extraordinarily complex machine. We saw 60 to 70,000 different proteins that have very specified functions. How did the molecules of life get organized? One can believe that a complex system like the living cell is capable of manufacturing large complex molecules from simple precursors. But the original manufacturing mechanism has to come from somewhere. Factories making CD players do not assemble themselves. Believers in abigenesis are forced to accept that life is a self-organized invention. So, he goes through different propositions of how life came about in itself. He basically shoots them down one after the other. He goes through all of them, and I must say I'm impressed with how objective he is. Outer space molecules and so on. He goes through one of the Russian scientists who was clearly a farce. He goes through. I'm thumbing through the pages here. He goes through the methane theory. He goes through every theory and brings very, very. He shows how vague they are, how really they're begging the question, and so on. Which came first? Amino acids have emerged from millet-type experiments, but not nucleotides. This brings us up against a fundamental problem. We have seen that DNA is responsible for the replication of the cell. If a primitive cell contained only proteins, it would have no future. It would be it, and that's it. A cake doesn't make cakes. You bake a cake, and that's the end of it. Proteins cannot replicate themselves. Such a cell would eventually age and die without progeny. We're not aware of immortal cells. On the other hand, imagine primitive cells with only nucleotides. We know that DNA can direct duplication of cells initially by duplicating itself, but that duplication needs certain enzymes. For DNA to function, it needs part of the cell. And in a cell with no proteins, DNA could not duplicate. Remember that all enzymes are proteins. Neither could such a cell direct the synthesis of protein, a process that itself requires enzymes. In any case, it is rather difficult to see how such an enzymeless cell would carry out the thousands of functions that are typical of a living cell, which depends absolutely on the presence of enzymes. So it stretches even the credulity of a materialistic abiogenesis fanatic to believe that proteins and nucleotides persistently emerge simultaneously. So we have this DNA and proteins come together, the right DNA with the right protein, the same point in space from the primeval soup. We are in trouble enough without adding the events of an astronomical improbability. One could, of course, say that the primeval oceans were so stuffed with amino acids that anywhere the nucleotides appeared, they land in the middle of amino acids. No one has suggested up to now, and it would require staggering amounts of carbon.
So,
yes,
really, is he saying here basically what we saw in the earlier book?
Yes.
Well, you need DNA in a protein cell in order to make more protein cells.
And you need the proteins there for the DNA to function.
In the first place.
Yes. And I added the part that DNA is actually not a material, it's a code. It's one thing when you see a cake and you say, how did this cake come? And you say, somebody spilled out flour and sugar. But when you see a shape and you see a cookbook describing the cake, I mean, the DNA is not material of any significance. The protein is a material that the substance was important. The DNA really it's just an instruction book, and that's it. He tries to work with RNA, and maybe by chance it happened. It's tough enough doing it in the laboratory, and no one has come anywhere near producing RNA by mixing simple molecules and subjecting them to the imagined conditions when Earth was young. Tries to come up with protein. He also explains that he also goes into the issue of the cell shell, that no one's ever figured out how to do it. A cell cannot exist in itself. It needs to have a sac around it. Its vesicles and how this happens and so on. Then the last piece that he has is called Back to Miracles. None of the present theories of the origin of life is strongly favored by the scientific community. In fact, I would not blame you if by this stage doubt is creeping into your mind. or is perhaps already firmly installed in the throne room. Francis Crick, who happened to be the one who discovered DNA, has written, "The origin of life appears to be almost a miracle. So many other conditions which would have had to be satisfied to get it going. The finger of God is certainly a tempting way out. The probability of a crowd of small molecules forming the needed large molecules to start the long complex process of a single cell seems to be almost zero." Going back to our 200, now, he started off that a human being is really $200 worth of chemicals. Going back to our $200 worth of chemicals again, no one would deny that attempting to create Kim Basinger, Mel Gibson by heating and shaking the mixture, although worth trying, might take forever. But that doesn't prove that life had supernatural origins. Up to now, in attempting to prove that it hasn't, we probably just made the wrong starting assumptions. The problem is that we don't know what the right ones are. Now, let's think about what he said. So, in a certain sense, he's restating much more forcibly the points we said. He is dealing with the issue of the complexity of life. But now I want to look at the human angle in this one. Here is a highly intelligent person, really an accomplished scientist saying, okay, I have this incredible complex entity in front of me called life. I have no theory that explains it naturally whatsoever. But I'm not willing to accept that someone outside designed it. So my question is now, is that objective? So when I say to myself, here's a person looking for the truth, and it's just like if I catch my closest friend on video shooting somebody, his fingerprints are on the gun. He can't explain where he was during that time. The video shows him shooting, and he had a reason to kill this person, and I keep denying it because it couldn't possibly be him, and the video was a frame up, they combined other videos, and they got his DNA on this, that. I ask myself, am I looking for the truth, or is this because I like the friend? So, for a friend it's okay. I don't understand if a scientist is objective. If he's willing to say, obviously I'm convinced that something has to design it, but as a scientist I have no way of quantifying it, explaining that, or dealing with it, fine. I'm good with that, because science does not need to deal with religion. It's not meant to deal with it. Cookbooks don't deal with all the kashrus. A science book should deal with the flat biology. But when you're coming now and peddling a worldview, like he says, the crusade of the book is to show how science took us out of the darkness of the creation story to the light of science, and you're telling me that Seichel has not come up even with a Havamina how it could be otherwise. It really questions, is he objective? I mean, and I want to explain, I guess going off tangent a bit, but like we started in one of our beginning shurim, it's hard a lot of times to separate the subjective from the objective. It's not, I don't think that this scientist is going to, he's explaining no emunah, so he shouldn't have to keep the Torah. I think it's a lot simpler than that. You grow up in a society, you go to college, evolution is the fact as clear as one of the books here says, as clear as it's as accepted today. This is in the Carter Encyclopedia has it on evolution. It is a theory today that is as acceptable as the world being round and the Earth going around the sun. In other words, denying it is as so you grow up in that environment. How would you feel if you would come up and say, Rabbi Isai, I think it's intelligent design? I mean, just like Lahavdil, a person who's brought up in a frum environment has certain restrictions, and he's not going to become a Soma Kofer. It takes a lot of Kofos and Nefesh to do it. It's somebody who's brought up in an environment where it's universally accepted as being fact, and you're a lunatic if you think otherwise. How objective do you really think his evaluation is? And basically, he's saying that. He's saying, here we have this incredible thing which demands somebody designed it. I have no alternative explanation for it, and yet I'm holding on strong because someday science will discover the alternative. Why? Is that a rational approach, or is that it has to be that way because there's no way I'm going to believe? Yes.
I mean, sometimes people refer to what's known as the God of the gaps, which is sort of what you don't understand, you say that's God, and then once you understand something, that's not God anymore. So, I mean, why is that an invalid approach? Because if you're going to say, well, this is God, it's inexplainable, but then you come up with an explanation that doesn't involve God, so that sort of sets a precedent of when I approach these problems, why should I sort of quote unquote blame it on God when I can help with another explanation later?
Well, let me give you an analogy or two. Every doctor goes with a certain sense. If a person comes in with the sniffles, a doctor doesn't test for a tumor in the nose, even though occasionally there will be the person who has a tumor in the nose and with sniffles. There's a famous saying, when you hear hoofbeats, it's think horses, not zebras. On the other hand, you get, these doctors write up these famous cases where this guy came in and seemed to be a regular cold, but on second thought and so on and so forth. You generally say to yourself, there are the exceptions, and, even when, and you need to take into account 1 in 1,000, 1 in a million, whatever it is, and there's a general rule. A doctor, in America today, where they pay for all this stuff, they send you for an MRI with every narrow type, but a general Bardas doesn't do that. So there are gaps that we didn't know, and we think we have a way to explain it, which is fine. But just because that one case, why would you something that's complex tells us was designed. Something that is so incredibly complex, that's our most basic approach to knowledge, is that there's a cause and effect, and we haven't come up with any cause except for that. So if a person says it's not 100% proof, I understand it, but that you're not willing to consider it as overwhelming evidence, and therefore you should be honest and say, I think at this point it does seem to me that there's some outside intelligence has brought this into the world. It's not absolute. I may find that would be a correct statement, but to present the problem and yet remain with the conclusion that he's remaining with, it does show a human fault. And I'm not saying he's a bad person. I'm just explaining that when people live in an environment, I remember a small thing. When I was young, ulcers were categorized together with heart attacks and cancer as being caused by the body itself running haywire. Whether it was stress or whatever it was. And a doctor that would have suggested a bacteria would have been lost his license to practice, would have been termed a quack. The people who actually found it was bacteria were snubbed, and they weren't given the time of the day, until finally the whole kochom was proven, and now it stands, we treat it with antibiotics, certain type of antibiotics. There is a general. Every scientist doesn't have all the facts and doesn't sit down and reinvent the wheel and reconsider it. He basically, a normal person goes along with the consensus of normal people. So the fact that people just accept it, I hate to use the muscle, but it's just like when you have 1,000 signatures on something, you know that 2 or 3 people really made the decision, and the other people say if they feel that way, we feel that way. Scientists don't sit down and rediscover things. Way too many things that I learned in school have been basically phased out, and even though the research was there already, but it takes time. The thinking of the scientists as a whole goes in a certain direction, and it changes very slowly. People do act as part of a large group, and people don't buck the system. And and you see it. Here's somebody, he has a certain attitude, and this attitude is not going to change. And this is a side point, I guess, which I went off because I think it's very important. I would actually I will make this point at the next stage when we speak about a complexity of things going from simple life form to more complex life form. There's also something like that I like to point out on a personal note, because it's kedai to remember the problem is science presents itself as science and not as scientists. It presents itself as a subjective, like a computer. Computer does not introduce any subjective elements. Science as a whole does not produce subjective elements. It's not true. People are people, and science as a whole has seen itself as coming to demyth our perception of the world. In a certain way, religion is fine for ethics and stuff like that, but it's certainly not, doesn't deal with the physical world, and that's an attitude. And b'meila, anything that we would not be able to explain clearly, we still say science will someday find a way out, and so on. Let's recap the points. We've dealt with the first part that should strike a person as being impossible. And again, I'm using the word impossible not 100%, but so improbable that he needs to ask himself, why am I thinking otherwise? Just like a judge when he's presented with overwhelming evidence and says, but, it's not 100%, you ask yourself, hey, why is it that you're so on a limb to make it 100%? The gap between non-living to living is not covered by anything we know. We can't even imagine a model that it would happen, because all the models deal with chemicals. Can we produce an enzyme under different types of conditions? Well, yes, in the laboratory we do it, so we could theorize the world. But an enzyme is not really a living thing. It's a chemical. A living entity is a cell, which means an organized form of existence that is so incredibly complex that it defies the imagination. You needed 60, 70,000 things in one shot to be viable. That's the key. It's not as sophisticated. You can't start off with one chemical and work your way up. A cell needs to have a way to bring in food, a way to identify food, a way to break down the food into simple components, a way to get rid of the things that are not necessary for it, a way to move. It needs a sense of direction. It needs a sense of shape. Bacteria all have very specific shapes, and they don't change those shapes. Those shapes are built in. We don't have a clue to that. And the most the most difficult of it is understanding DNA itself. DNA is a book. It's a code. Imagine finding a book on how to create life and saying that came about as an accident, concurrent with the accident of life itself. It works in a cell in a way that is so interdependent on two levels. DNA in itself means nothing. It's like writing a book about a country that doesn't exist. Imagine somebody writing a book about Bulgaria 1,000 years before it existed, describing Bulgaria. There was no Bulgaria. There is no Bulgaria. What does it mean having a code, a DNA code, for things that haven't happened yet? That certainly couldn't come about by an accident. It would be meaningless. There's no reason to have a code for something that doesn't exist. And on the other hand, proteins coming together without a code are finished. You'd need the miracle of creation again and again. And at what point, DNA doesn't, a half a string of DNA, a quarter of a string of DNA doesn't mean anything. Besides which, it is the DNA needs the proteins to survive, the proteins need the DNA to survive, so they're interdependent also on the physical level. Those are the extraordinary, almost impossible way of finding a natural of itself. The key word being without any guiding hand for it to happen, without something on the outside putting it into place, and that something on the outside, the thing we can say about it is it is able to create something with 60 to 70,000 pieces that fit together, work together, are written in code, and have a structure that they can complement each other, and is a being that is able to survive. It's able to keep itself against outside elements. It can bring in material to build itself. It can get rid of material that destroys it. It can move away from danger and move towards things that enhance it. Yes?
Sort of to add on to this, you could even say that if you want to, say the statistics of the DNA in the cell actually coming spontaneously at the same time was 1 in a billion, or whatever you want to say, 1 in a trillion, whatever you want to say the number is, there's still, you would need that to survive. I mean, that could have happened at one time, and then who knows, like a wind could have blown, or like...
Right. It really happened to recur many times. Next time, I want to look at one or two arguments that are also powerful arguments, but have flaws in them. And I think it's important when we speak about the different ways of looking at it to try to understand, because if once you're dealing with it, you will hear other arguments, and there are flaws in those arguments, and I would like to present them as well. And then I'd like to move on to the next stage, which is going from a simple molecule, simple cell, to a complex being, and the gap from biological entities to man. Okay, we'll hold it now. 40 minutes.